Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, we're going to actually start on now the next subtopic in our booklet on climate. And the subtopic that we are moving on to now is looking at climate. We have just completed work on looking at weather, the different elements of weather, and also the different instruments that are used for measuring those different elements of weather. So if you can make reference now to your booklet, Introduction to Climate, and then we will look at the introduction part that is presented in our booklet. Then we will move over to looking at what I'd like us to cover in our lesson, and that is basically looking at some of the controls or factors which contributes to what makes climate different from one place to the other. So if we look at the word climate, in the beginning when we were looking at information about differentiating between climate and weather, we found out that weather is generally looking at the daily conditions of the atmosphere. Whereas for climate, climate deals with the average conditions of the atmosphere over a longer period of time. The definition is important that you remember. There are three important factors which also comes in with the definition of climate, and that is factors which are 1, temperatures, pressure, and precipitation. So when we are dealing with the conditions of the atmosphere over a longer period of time, we basically look at those three factors. And the three factors again are temperatures, pressure, and precipitation. So when we try to explain the climate of a particular region, we will need to look at those three factors to give a description. Say, for example, what is the climate of Papua New Guinea like? Our answer would be hot and wet. When we look at the word hot, it describes temperatures. When we look at the word wet, it describes precipitation. So for the controls, sorry, not controls, but the factors which are explained a little bit more in depth will be mainly pressure, temperature, and precipitation. And those three controls are found in our booklet also. Our approach is going to be, we are going to look at each one of those controls and how they contribute also to variation in climate. So we will start off with the first control, and that is temperatures. Looking at temperatures, generally, we will need to go back to what we have covered already on solar radiation, because it is from that energy from the sun that we do have the differences in temperature from one area of the world to the next. So when we are looking at temperatures, it is basically looking at how hot or cold a particular place is. But note that temperatures throughout the world, it varies. If you are at the equator, the temperatures are different from when you are at the poles. If you are at sea level, temperatures will be different from when you are at a higher altitude. If there is cloud cover, that cloud cover may contribute to variation in the temperature. The distance from the sea also has an influence in the variation in temperatures. So what we are going to do now is we look at solar radiation, the incoming energy from the sun, and how that incoming energy from the sun gets to warm up our surface. And then after we look at that information, then we will move on to looking at least two factors or two controls that makes temperatures different from one place to another. Okay, looking at this diagram that we have on our monitor, the first part of it is simply what we have covered already when we looked at solar radiation. We note that incoming sun's energy, that's about 100% of it that comes through to the surface. We already found out that the Earth is at a distance of 150 million kilometers from the sun. From that distance, not every rays from the sun comes to the Earth. It's only a small proportion that actually is used to heating up the Earth and its surrounding. From that small proportion, if we are looking at, for example, from that small proportion coming through, 100% of it, not the whole 100% will reach the ground. Along the way, we have already learned that certain percentage of that energy is actually absorbed by the atmosphere. Certain percentage is actually reflected or scattered by the atmosphere and also from the Earth's surface. What is remained is about 45% or 50%, and that is what reaches the ground. That 50 or 45% that reaches the ground becomes insolation. And insolation is simply the amount of solar radiation that reaches the Earth's surface. Okay, from that 45 to 50%, what then happens is that the heat from that 50 to 45% is therefore radiated back into space. It is conducted, or through the process of conduction, it also passes back up into the atmosphere, and also through the process of convection, that heat also is transferred or passes back up towards the atmosphere. While that takes place, the process of radiation, conduction, and convection, what that contributes then is it contributes to warming up our Earth. So it is from that 50% that reaches the ground, insolation. It does not reach the ground and stay there forever. It reaches the ground, and then the three process of how the air is warmed takes place. The air then around us is warmed through the process of radiation from that 50 or 45% insolation. The air around us is actually warmed through the process of conduction, and the air around us is actually warmed through the process of convection. I'll give you 1 minute, and from that 1 minute, perhaps you might want to make note, especially of this information here on how the air is actually warmed. Okay, having mentioned that, perhaps a definition to radiation, conduction, and convection might help you see how the air is warmed a little bit better. Okay, we look at those three different ways in which contributes to how the air is warmed. Through the process of radiation, what happens here is that heat waves are sent out by the Earth's surface. We've covered radiation already. Whatever actually comes through and whatever is sent out by the Earth's surface is sent out in the form of long wave radiation. And that process is referred to as radiation. So in simple terms, we can say it is mainly to do with the heat waves sent out by the Earth's surface. In other words, we can say it is the transfer of energy emitted by the sun and through a medium or by means of electromagnetic waves at different wavelengths. From what we have covered, we looked at radiation, short wave, long wave, The long wave radiation are the ones that are actually sent back out into space. And whatever is sent back out can be used also to warming up the atmosphere or the air around us. So this is one way in which the Earth is actually warmed. Okay, the second one is through the process of conduction. And conduction is simply to do with the passing of heat by contact. So the passing of heat by contact. Here, when two objects at different temperatures are in contact, heat flows from the warm to the cooler object. And the heat exchange is called conduction. I'll repeat that. When two objects at different temperatures are in contact, heat flows from the warmer to the cooler object. And the heat exchange between those two objects is referred to as conduction. In simple terms, conduction is simply the passing of heat by contact. And finally, the third way in which the atmosphere or the air around us is warmed is through convection. And perhaps the word convection you might have already heard when we are looking at rainfall, when we are looking at air currents or air movements. Convection rainfall, convectional rain, we have convection currents. And when we are looking at convection, it is mainly to do with passing of heat by air currents. A good example we might look at is that when the earth or when the sun hits up the surface, what happens to the air in that area that the sun hits? The air rises, yes. Upon rising, it will then cool. Then it may go through the process of condensation, and then precipitation occurs. So the rising of that air as a result of heating of the earth's surface is referred to as convection. So it is simply the passing of heat by air currents. That's what we mean by convection. These are the three ways in which our planet Earth, especially the air around us, is actually warmed. Any questions or queries with regards to that information? No questions? Okay, if there are no questions, we'll move on. When we talk about temperatures, we all know that temperatures can vary from one location to another location. On the monitor there are some factors or controls that affect temperatures. And some of those factors and controls are, number one, temperatures vary due to latitude. Temperatures can vary due to altitude. Temperatures can vary because of ocean currents. We also have the distance from the sea can contribute to variation of temperatures. Temperatures can differ due to the winds. Temperatures can also differ due to aspect. Number 7, cloud cover. Number 8, length of day. Number 9, amount of dust and other impurities in our air or in the atmosphere. So those are some of the ways in which, or some of the factors that contribute to what makes temperature different from one place to another. Our task today is going to be looking at least the first example of what makes temperatures different from one place to another, and we will simply look at latitude and how latitude can contribute to variation in temperature. Throughout our maybe lessons on the work on climate, then we are going to look at each of those different factors, and we will discuss them a little bit more in depth. Okay, have you made note now of those factors? Okay, these are some of the factors that contributes to what makes temperatures different from one place to another. You will also find those factors in your booklet, Introduction to Climate, and they come in letters A, B, C, D, E, F, and G. Okay, let's look at the first factor now, and we'll discuss that a little bit more in detail. Remember when I started, I said that these are some of the factors which contributes to what makes climate different from one place to another, or factors which contributes to what makes temperatures specifically different from one place to another. Okay, one of the things that also has an impact on variation in temperature is simply to do with hotter towards the equator, colder towards the poles. In other words, latitude. When we talk about latitude, we are looking at the distance that we go away from the equator. Generally, when you are at the equator, what type of temperatures would you expect at the equator in comparison to the poles? It would be hotter, yes, definitely. At the equator, it is a little bit more hotter than at the polar regions. Let's look at why that is so. So the first factor now, latitude. Because of the Earth's curvature, the solar radiation is much more concentrated where it arrives almost vertically near the equator or in the low latitudes. Why do we say low latitudes? Why is the equator referred to as a low latitude? Because it starts at 0 degrees, yes. So if we have to look at our latitude again, latitude is actually measured in degrees. The equator is at 0 degrees. And because it's at 0 degrees, it can also be referred to as a low latitude. The poles, they sit at 90 degrees. This is to the north, and here we have 90 degrees to the south. We don't go 91, 92 degrees because 90 degrees then is the furthest point that we can go to in terms of latitude. So the 90 degrees, north and south, will be referred to as high latitudes. And the high and low depending on whether we are at 0 or whether we are at 90. So here at the equator, the solar radiation is much more concentrated where it arrives almost vertically in that region or in that part of the world. The further one goes away from the equator towards the poles, the lower the angle of the sun's rays arriving at that surface. So if I had to draw the sun on this diagram here, we have the sun here. The energy from the sun is actually almost vertical at the equator. And as we go away from the equator, what happens now is that the energy from the sun arrives at an angle. This diagram might help explain that. Here, at the equator, energy from the sun is almost vertical. As we get to the poles, the energy from the sun is actually at a lower angle in comparison to that at the equator. Okay, we move on. Nearer the poles this time, the high latitude areas. Nearer the poles, the north and the south poles, the sunlight comes in at more of an angle, and the amounts of energy have larger areas of land to heat up. At the equator, the energy from the sun is almost vertical. Note, the heat is actually concentrated on a smaller area. Whereas at the poles, because the sun's energy comes at an angle, the heating then, the area that is actually heated in comparison to that at the equator is more than that at the equator. So you have a larger area, or there is a larger area that the sun has to heat up compared to at the equator where the area is smaller. As a result of that, as a result of the heating, then what happens is that because the sun is concentrated to a smaller area, the temperatures here are more intense compared to the temperatures towards the north and the south pole. Because the area is larger, the heat is actually spread. It is not concentrated. Therefore, the temperatures around the polar regions or away from the equator are a little bit more cooler. Okay, let's look at the diagram. And that diagram should help us understand the relationship between temperatures and latitude. The yellow color here showing us the sun's rays. Two areas that we have discussed, the low latitude or around the equator and the polar regions. It would be similar for the southern hemisphere also. The X rays, they represent the band of light coming through or energy from the sun coming through the surface. Note, at this point here where B is, you have a smaller area that the sun is heating up. The ray is coming at almost vertical towards the surface. Therefore, the energy around here or the heat is more concentrated. It will be hotter around this region. We come to area A. Area A, energy from the sun coming through, but it's coming at an angle, not vertically. And because it's coming at an angle, note, the heat is a little bit more spread. And because of the spreading, that means that the heat is not intense as that of area B. Therefore, the temperatures around here would be cooler. And that's what we are making reference to in terms of the relationship between temperatures and latitude. Any questions? Questions from the class? Do you understand this, the relationship then? Do we understand the relationship? Yes? Okay, we move on. While we are looking at latitude, here is something else that we also need to consider, and that is the second maybe way in which that contributes to variation in temperature from region to region. We all know that it is usually hotter by day and cooler by night. Is that true? Yes, okay, so we have the second example now that also has to do with what makes temperatures vary from one place to another. By looking at the heading there, hotter by day, cooler by night, one can say that because the sun provides the earth when it's heat, or with its heat, I'll repeat that statement again, sorry. Because the sun provides the earth with its heat, it is naturally warmest when the sun is shining on the earth. Therefore, it will be warmer by day because that's the time when the sun is shining on the planet Earth. Therefore, it will be warmer by day compared to by night. Make sense? Yeah. Okay. Perhaps you make note of that quickly and we'll move on. We're still looking at hotter by day, cooler by night. Okay, looking at that information, hotter by day, cooler by night. During what time of the day do you think the temperatures will be at its maximum? At noon. You definitely think it's at noon? Okay, at what time of the day do you think the temperatures will be at its lowest? Afternoon is like from what time to what time? Give me an approximate time. About 6 o'clock to 7 o'clock in the night or in the morning? Okay, we're looking perhaps at a 24-hour span here. So you're telling me at 12 o'clock during the day, that would be the hottest time of the day. The temperatures will be at its maximum. About 6 o'clock to 7 o'clock in the afternoon or PM, that's when you think the temperatures will be at its lowest. You agree with that statement generally from the class? No? Why not? Val, why not?
The earth would have been heated up by the sun, so it'd be hotter in the afternoon, so it'd be cooler in the mornings.
Val thinks that during or in the mornings it would be cooler, in the afternoon it will be hotter. Because the earth is actually heating up, and by the afternoon that's when the place becomes a little bit more hotter compared to in the morning. Okay, that's a point. Any other students think that maybe the statement here, in terms of you telling me it's at noon or at 12 o'clock, that's the hottest time of the day, and at 6 o'clock it's the coolest time of that day. Mason?
It can't be from 6 o'clock to 7 o'clock in the afternoon towards the night, because the earth is still taking time to cool down, so it'll be still a bit hot.
You could be correct, definitely. So when do you suggest would be the coolest time?
O'clock in the morning.
You think it is 6 o'clock in the morning?
Yeah.
You could be correct. So you're telling us that at noon, that's the hottest time, where the temperatures are at its maximum. At 6 o'clock in the morning, 6 a.m., that is the time when it is the coolest. Okay, let's check this one out and see if we can understand what we mean hotter by day, cooler by night. One might have expected the hottest time of the day to be at midday, like what we have just mentioned, or at noon, when the sun is actually shining most directly on the surface. But this is not the case. Okay, we are saying that noon is supposed to be the hottest time of the day, but here that is not the case. Why? The hottest time of the day is not midday, but it is mid-afternoon. The heat builds up more and more in the atmosphere, even though the effects of the sun are decreasing after noon. So therefore, definitely, it is not 12 o'clock or noon that we have the hottest time of the day. It would be usually the mid-afternoon. That is when we have the hottest time of the day. We check this information out. Also, in the coldest time of the day, the coldest time of night, it will not be during the day, because the coldest time now will have to be in the night. And the coldest time of night occurs at the end of night, just on dawn, when the heat or when the heating process of a new day is about to start again. So 6 o'clock, it's already dawn. So just before dawn, that is when we have the coldest time of the 24 hours. Let's check that out by looking at a graph. And then perhaps from that graph, we might be able to see what we mean by temperature variation in the course of 24 hours, hotter by day, cooler by night. If we have a graph to show that, on the vertical axis, we have the temperatures, low temperature here to the high temperature. On the horizontal axis, I have from 9 a.m. in the morning, 12 noon, 3 p.m. in the afternoon, 6 p.m. in the afternoon, 9 p.m. in the night. We're looking at midnight for this line here, 3 a.m. in the morning, 6 a.m. in the morning, and 9 a.m. in the morning. You'll definitely be correct by saying 6 a.m. according to this graph. Okay, so here we have the energy from the sun heating up the surface. Temperatures start to rise. By the time it is 12 o'clock, temperatures are here and it is still rising towards mid-afternoon. By the time we reach about 3 p.m., that is the time when the temperatures are at the highest, mid-afternoon. And then after that, temperatures start to decrease. Okay, we go for that time to midnight, and then to 3 a.m. in the morning, and then finally we come to about 6 a.m., the start of a new day again, where the temperatures would be the coolest. And then the increase in temperature again as we start the next 24 hours. So you are definitely correct to say that temperatures are coolest at about 6 a.m. in the morning. And that is also what Val said, is that right? Yes, she also mentioned 6 a.m. in the morning. Okay, so the statement that we are looking at is hotter by day, cooler by night. And the reason for why it is hotter by day, cooler by night is simply because we know that the sun is actually shining most directly on the surface during the day, and during the night, the area that the sun is actually not shining on is in its own shadow. Therefore, the temperatures are actually decreasing. By the time it is 6 o'clock the next day, that's when temperatures would be at its lowest. Okay, perhaps I will give you time for those students who are copying to make note of this, and then we'll move on to looking at some activities based on those two factors that we have just looked at on latitude and hotter by day, colder by night. Made note of this? We'll move on, okay? That's a continuation on the topic on hotter by day, cooler by night. Okay, all made note of that information? Okay, now to the 3 activities. And the 3 activities will be based on what we have looked at on latitude and hotter by day, cooler by night. The questions are, number 1, you have to explain in your own words why days are warmer than nights. Number 2, explain in your own words why the warmest time of the day is usually mid-afternoon. And number 3, why is it hotter in low latitudes than in high latitudes? I'll give you at least 5 minutes for those 3 questions, and we will look at the answer together. You were not able to make note of all of that, the other statements there.
Yeah, I've made note of it.
Okay. Space for your diagram. Okay. No, they have not got it printed out, so it will be from the monitor. Oh, okay. What was it again that you mentioned? You said temperatures are cooler by,
Cool in the morning and the heat, all the heating of the earth heats up. Oh, and just now
I mean the answer that you gave, you said cooler in the morning and hotter
in the afternoon.
afternoons, and then you are correct definitely in what you have said, but we went specifically to looking at the time. So you are definitely correct, yes. Is that my book or is it your own book? You got some answers? Put it down, write it down so you can. Okay, we'll need to give answers to those three questions. Christopher, your answer for question number 1, why are days warmer than nights?
Because the sun heats up the Earth's surface during the day, thus the days are warmer than the nights.
Okay, very good. It's simply because the sun shines on the Earth's surface during the day, heating up the Earth's surface. During the night, it does not actually shine on the Earth. Heat escapes during that time. And that's the reason for why it is hotter during the day compared to in the nights. Okay, good. We move on. Question 2, why are the warmest times of the day usually mid-afternoon? Or why the warmest time of the day is usually mid-afternoon? Shelley, Kali, your answer.
Because midday is when it's still when the air is still, it's still warming up, but then coming towards mid-afternoon, that's when heat is building up, and yeah.
Okay, maybe she's got the idea there, definitely. We know that by midday, the heat is still increasing. By mid-afternoon, about 3 o'clock, that's when the heat is at its maximum. And that's the reason for why the warmest time of the day is not usually at midday, but rather mid-afternoon. After it reaches the mid-afternoon, then the temperatures start to decrease. And the decreasing goes until the next morning, where the sun comes up again and the heating starts again. During that process also, at about 6 a.m. the next day, we'll also find that that is the time when the temperatures would be usually at its minimum. Okay, good. Finally, the last question. Elsie, why is it hotter in low latitudes than in the high latitudes?
I think it's because the sun rays, they shine directly on the low altitudes.
You're definitely correct. More information? They shine directly on the low latitudes, therefore
Therefore, it's more hotter than the areas in the high altitude.
okay. We're looking at latitude, that is supposed to be, not altitude. The sun is actually directly or almost vertically above the low latitudes. Therefore, it is warmer or hotter around the low latitudes in comparison to the high latitudes. So when we look at our diagram here, the diagram should explain that particular question. More intense heating around the equator, therefore it's hotter here. Less heating towards the poles, therefore it is cooler along the poles. Okay, with that information, that also brings us to the end of our lesson. Class, if you can stand up now. To the pilot teachers, our keyword for lesson 104 is conduction. Good afternoon, and thank you, students.